The next several videos will be about factoring, and they're broken into small steps. These steps represent the order in which you want to attack a factoring problem. You always want to start with this first one, which is factoring out the greatest common factor, and then we'll move on from there in steps that should hopefully make sense and help you be able to factor. It's a very important skill to be able to do in Algebra 2, and you're going to see it several more times throughout the year. So first we need to make sure we understand what a factor actually is. And so kind of a generic definition of a factor is that factors are numbers that multiply, numbers or expressions that multiply together to give you another number or expression. Now, at some point, you should have done factoring trees. So, for instance, maybe you had 36 and you broke that down into 6 and 6. So sixes, a 6 is a factor of 36. And then you normally would keep going. Factors of 6 are 2 and 3. And of course this 6 would be 2 and 3. So factors of 36 are 2s. Or a 2 is a factor of 36, a 3 is a factor of 36, and a 6 is a factor of 36. Now this last line here is the prime factors of 36. And if you remember, prime means that nothing except 1 in itself can be divided into it. So if we wanted to write 36 as, their prime factors, 36 would be 2 squared times 3 squared. Okay, and so you should have seen this at some point when you're factoring, doing factor trees. Now your standard monomial is actually written in factored form. Now it's not prime factored form all the time, but if we take something simple, for instance, like 12x squared y cubed, there are factors of 12, there's factors of x squared, and there's factors of y cubed. So if you're really up on your exponent rules, you could say, well, this is 12 times x times x times y times y times y. Okay? And if you wanted to break 12 down into its factors, right, you can do a little factor tree, 2 and 6 and 2 and 3. Okay, so really 12, the factors of 12x squared y cubed could be written as 2 times 2 times 3. That would give you the 12. Times x times x times y times y times y. Okay, so these are all a bunch of factors, and when you multiply them together, they would give you 12x squared y cubed. Now, none of this should be really too much news. Hopefully, you kind of had thought about that before. But so what we're really concerned about is factoring expressions. Okay, and think of an expression as a binomial or bigger. So when we're factoring, what we're doing, it's kind of like doing multiplication in reverse. Okay, so if you understood how to FOIL or multiply any other polynomial together, we're going to go backwards from your answer on those. To factor an expression means that you're going to write the equivalent expression that is a product. Okay, and you have to, when you're doing factoring, you have to get it down all the way to basically the way you would look at it is its prime factors. So GCF stands for greatest common factor, and when you are thinking of more than one term, a greatest common factor would be the biggest number in this. When I say number, that includes variables. So the biggest group of numbers and variables that you can divide into every single one of the terms. Okay, and this is something that you should have been talking about when you're dealing with reducing fractions. Okay, so let's just look at this first example here. You have a 9 and a 12, and so you're thinking, what's the biggest number that I can divide into both 9 and 12? Okay, and that would be the greatest common factor. The biggest number would be a 3. Okay, but again, it doesn't have to just be numbers. We can also involve variables. So if we're looking at this next one, this is an xz and this is an xy. So what's the biggest number? In this case, our number will be a variable. So what's the biggest variable that both of these terms share? Okay, and so in this case, it would be an x. Okay, now there's combinations of this, right? 7xz and 7yz. What's the biggest number that we can divide into both of those terms? Well, we can take a 7 out, and we can also take a z. So a 7z could be divided into both of those terms. Okay, and so just for one more example here, you can take out more than just one x, or more than just one variable at all. So, but you go through each individual thing. When you're dealing with trying to figure out what the greatest common factor is, you have to go through and break it down into a couple smaller problems. So you're just starting with the coefficients here. What is it that can go into both 2 and 6? Okay, well, so that would be a 2. Okay, what's the biggest amount of x's that we can divide into both of these? Okay, so there's only 2 x's here. There's 5 here, but the biggest thing that we can take out of both of them, or divide into both of them, however you want to think about it, would be an x squared, because there's only, you can only take out as many as each of them have. Now they both have one y, so we can also take out a y. All right, so that's basically factoring out a greatest common factor out of a polynomial. Now, remember, polynomials are terms that are added and subtracted. So you're not just looking for and trying to identify the greatest common factor, but you need to have in your answer an equivalent expression. Okay, so you have to have all the factors listed out. So there's a slight twist to this. So all of these factoring videos are set up in a very specific way. If you stick with this list, okay, and the list being always check to see if there's a greatest factor that you can pull out first. Okay, if you stick with this list, factoring isn't a big deal. If you forget a couple of the steps, then you can get yourself confused. There's going to be some polynomials that you cannot factor any further unless you take out a greatest common factor first. So if you're forgetting this first step, and this is always going to be your first step every single time, and I can't say that enough, right? I said it like 5 times. Always check every polynomial for a greatest common factor and start from there. Then you can move on to the next steps, which will be some of these next videos. Okay, so here is 2 polynomials, and all we want to do right now is figure out if we can take a greatest common factor out of all of the terms that we see. Now again, when you're doing this, when you're doing any factoring, you have to have an answer that you can multiply back to get the original expression. That's when you know you have a factored, a factored expression. Okay, so we have to write this in a very specific way. So we're looking at 4y squared minus 8. Okay, and we're saying to ourselves, what's the biggest number that will go into both 4 and 8? Okay, and you should think of a 4. Now, again, this is not your answer. Okay, that is the greatest common factor, but your answer needs to be something that when you multiply it back to itself, multiply all the factors that you found together, you better get the original expression. Now, 4 by itself will not get us 4y squared minus 8. So this is the second part of this. You have to ask yourself, what times my factor, what did I take out? So what times my factor gives me every single term that's left over? So what times 4 gives me 4y squared? And then you should think that's 4. That would be y squared. Okay, and then you go to the next term. So what times 4 gives you negative 8? And make sure you pay attention to your signs. Okay, so what times 4 gives you negative 8? That should be a negative 2. Okay, now the next set of, as we go on through this list of steps of factoring, there's ways to check to see if we're actually done. Right now we're not worried about this, and actually this is as factored as it's going to get. But it's a very simple thing to check, right? All you have to do to know if you have the correct factors, and this is something you should definitely do. Once you get used to it, you might be able to skip this a little bit, but always check. Okay, it's very simple to check. All you have to do is distribute the 4 back through. Okay, so 4 times y squared is 4y squared. 4 times negative 2 is negative 8. Okay, so these two things are the same, so we know that we have factored it correctly. Let's go on to the next one. Okay, you're saying to yourself, we got a couple different multiple repeating factors in each of these terms. So you got to break it down into small parts. Just look at the coefficients. What's the biggest number that can go into both 5 and 20? Okay, you should be able to say that's 5. Oops. Okay, now we're going to move on to the x's and say to ourselves, what's the most amount of x's that we can divide into both of these terms? Well, the biggest amount happens to be the smallest exponent. Okay, so we can take out x cubed. So we're going to say our greatest common factor is 5x cubed. Now again, we're not done because we need to write what's left over. And this is where you have to say to yourself, what times 5x cubed gives me 5x to the 4th? Well, 5 times 1 is 5, and then x times x cubed would be x to the 4th. So we're just having an x left over. Okay, now go on to the next one. What times 5x cubed gives you 20x cubed? Positive 20x cubed. So that would be a positive 4. Again, it's very simple to check. Right? All you have to do is distribute back to make sure you get the original expression. 5x cubed times x is 5x to the 4th. 5x cubed times 4 is plus 20x cubed. I just ran around. 20x cubed. Okay, so I'm just going to run through some more examples of factoring out a greatest common factor. So in this first one we have 12x squared y minus 20x cubed y. And again, we're just going to go through and look at just the coefficients first. What's the biggest number that you can factor out of a 12 and a 20? All right, and then that should be a 4. What's the biggest amount of x's we can take out? Well, we can take out an x squared, and then we can take out a y. And now we're going to go back through. What times 4x squared y gives us 12x squared y? Okay, so you can go through this one step at a time, just kind of like how we decided what our greatest common factor is. What times 4 gives us 12? 3. And then 1 times x squared gives us x squared, and 1 times y gives us y. So that first term that's left over in this factor is 3. And then we're going to say what times 4x squared y gives us negative 20x cubed y. So 4 times negative 5 gives us negative 20. X times x squared gives us x cubed. And then the y is also taken care of. Alright, now we're going to add more terms as we go. But there's nothing any different between this process and one with just 2 terms, right? Except for you have to make sure that your greatest common factor is going into all 3 of the terms in this case. So we're going to look just at the coefficients. We got a 10, a negative 4, and a negative 2. So the biggest thing that can come out would be a 2. And now we're going to move on to the p factors. So we have a p to the 6th, a p to the 5th, and a p to the 4th. The biggest thing that can come out of all three of those terms is a p to the 4th. Now we're going to move on to the q's. Q squared, q cubed, q to the 4th. The biggest thing that can come out of that is q to the 2nd. Okay, and now what's left over? That's a very important step to go through. What times 2 p to the 4th q squared gives us 10 p to the 6th q squared? Well, 2 times 5 gives you 10. P squared times p to the 4th gives you p to the 6th, and now the q's are already taken care of. So let's move to the next term. What times 2 gives us negative 4 would be a negative 2. What times p to the 4th gives us p to the 5th, and that should be a p. And then what times q squared gives us q to the 3rd, that should be a q. Alright, now on to the last term. What times 2 gives us negative 2? That would be a 1, a negative 1. So you can write negative 1, or you can just write negative, negative and then any variables, but make sure that, if you took out all the variables, you get this 1 in there, and that'll come up later if you're not sure exactly what I mean by that. But all the p's are taken care of because we have a p to the 4th and a p to the 4th. But what times q squared gives us q to the 4th? That should be q squared. And again, you can always check these by redistributing and seeing if you got the original. Here's a couple more examples, and the reason for doing these is that you should notice that the leading coefficient is a negative. Now, as we move through our steps of factoring a polynomial completely, usually what you want is that your first term of what you are factoring to be positive. Now, this isn't super necessary. Sometimes it is. Okay, sometimes if you don't factor out the negative, you won't know what to do won't know what to do next. But sometimes it's not important. Okay, but usually what you want inside the parentheses of a factor is that the first term to be positive. So we're actually just going to factor out a negative greatest common factor in this case. So again, we're just looking at each term and saying what can come out of both of those. Well, we can take out a negative 4, and then what times negative 4 gives us negative 4x? That would be a positive x. And then this is where you have to be careful. What times negative 4 gives you negative 24? And that would be a positive 6. Okay? Now you notice that the first term inside of our parentheses is positive. This is factored completely, but as we move through the steps, there will usually be times where this polynomial inside is still factorable. And it is very helpful to have it to be positive. Now again, make sure you pay attention to your signs. Very, very, very important. Okay, and it is easy just to check. Negative 4 times x is negative 4x. Negative 4 times positive 6 is negative 24. So when you're factoring out a negative, all the signs will be switched. Okay, so let's look at this other example. We're going to take out a greatest common factor, and again, I want what's left in the parentheses to have a positive first term. So as I look through the coefficients, I want to take out the biggest one I can, which would be a negative 2. So we're going to take out a negative 2, and you should notice that the greatest common factor of the x's would be just an x. So we're going to take out a negative 2x, and we're going to fill in the rest. What times negative 2x gives us negative 2x cubed? That would be x squared. What times negative 2x gives us positive 6x squared? That would be a negative 3x. And then finally, what times negative 2x gives us negative 10x? that would be a positive 5. Now that is completely factored. Okay, we're going to do a couple more examples of factoring out the greatest common factor, and they're going to start looking a little bit different, but the idea is still the same. Okay, at first glance these look like there's a whole bunch going on, but one of the things that you want to be able to do is to identify a term when you see one. Okay, and so I think that you would see, if you remember that terms are broken up by pluses and minuses, I think you would agree that this would be a term plus a second term. Okay, now what we're going to do is kind of the same. We're going to look for something in common that both of these two terms have. Okay, and they both have this factor of x plus 5. So that's what we're going to take out of both of them, x plus 5. And we're going to be left with, you want to go through the same process. What times x plus 5 gives me 3 times x plus 5? Well, that would be a 3. What times x plus 5 gives me 7 times x plus 5? And that would be a 7. Now, if you can simplify, you should. You're always working on simplifying expressions. So if there's any like terms like there are right here to combine, then we should do that. So this finally would be 3 plus 7 is 10 times x plus 5. Okay, now on to the second one here. Right, again, here's one of our terms, and here's our second term. And what do both terms have in common? Well, they both have an a minus b. And so that's what we're going to take out, an a minus b. And you're going to go through and see what's left over. What times a minus b gives you 4x times a minus b? Well, that would be a 4x. And then what times a minus b gives you negative 3 times a minus b? And that would be a negative 3. Okay, for our final two examples, we're just making bigger problems. So, we have two terms again, and we're still looking for what's the biggest thing that we can take out. And if you notice, both of these terms have a factor of 2x minus 1, so that's what we're going to take out front, 2x minus 1. We're going to ask ourselves what's left over. So the first thing that's left over would be a 2a plus b. The second thing that's going to be left over is going to be a plus 7b. Okay, and we're looking for like terms to see if there's anything we can combine. We have a 2a plus a and a b plus 7b. Okay, so when we combine our like terms, our final answer is going to be 2x minus 1 times 3a plus 8b. Alright, now the final one we're going to do, you have to be very careful because we have this subtraction sign. So it's very similar to the one we did up here, except we're going to be subtracting. And just like any other time you're dealing with a negative sign, you got to be very, very careful. Okay, we're again looking at this first term and this second term. And they both have an x plus y in front, or in their term. So that's what we're going to take out front. So we have an x plus y. Now what we have left over in the first term, we have a 3a minus 7. And we're going to subtract now, and this is where you have to be very careful, an a minus 4. So when we go about combining our like terms, we have to watch out for this subtraction sign. So our final answer is going to be x plus y. I'm running out of room, so I'm going to write down here, times 3a minus a, 2a. Negative 7 minus a negative 4 is negative 3.